In the last video, I mentioned that we would be looking at 4 different transformations, and that's what we're going to be doing here. So the first one we're going to look at is dilations. And we're actually going to look at basically 3 different dilations, which I'll come back to. So first of all, let's just use my initial example in the previous video, so the 0.32. And let's just take a look at a couple different things we could do. We could dilate this by moving it further or closer, further away or closer to the x-axis. So this would be a dilation with respect to the x-axis. And in this case, let's say I moved it up here to 3, 6. That would be, this example would be dilation by a factor of 3. Or maybe I move it down here to the 0.3, 1. This would be a dilation by about a half. Whoops, this would be a dilation by a half. And so notice in each of these, the x value stayed the same and the y value changed. So when we're dilating with respect to the x-axis, that means that we're doing a dilation of the y-coordinate. So that's the first type of dilation we'll look at. Similarly, I could dilate with respect to the y-axis. And in this case, that would be a dilation using this similar reasoning as what we just saw. That would be dilation of the x-coordinate. And finally, I could also dilate with respect to the origin. And what this would mean is I'm actually changing both x and y. So if I'm going back up to my diagram here, that means I'm either getting closer or further away from that origin point. And so in this case, both x and y change or get dilated. So we essentially have 3 different types of dilations that we're going to be looking at, and we'll take a look at the matrix for each. So let's start off with the y-coordinate dilation. And let's just do the general form of the matrix first. So in this case, the transformation matrix is going to be 1, 0, 0, and then this last value can be whatever we want the dilation to be. So I'm going to put a b there. And so this is a dilation of the y-coordinate by whatever b happens to be. For example, if I said 1, 0, 0, 3 times my vector 3, 2, notice that the first term is going to be 1 times 3 plus 0 times 2. So I'm just going to have a 3 there. The x doesn't actually change. And then it'll be 0 times 3 plus 3 times 2. So the next one's going to be 6. So notice how the x value is the same, and the y value got multiplied by 3. So that's exactly what we saw in the previous example, where I'm dilated away from the x-axis to the 0.36 here. That's exactly what we're seeing here. So we would say that this was a dilation by 3 of the y-coordinate, or you could say with respect to the x-axis. It's kind of up to you how you want to do that. But the y-coordinate got dilated by 3. So this is either a formula you can write down or you might just remember it. You don't necessarily have to worry about it too much, but that's y-coordinate dilation. If I wanted to do x-coordinate dilation, that would just be the matrix A, instead of a 1 there, 0, 0, and then a 1 in that position, would end up just dilating the x-coordinate rather than the y-coordinate. So this would be a dilation of the x-coordinate by whatever A happens to be. You could come up with your own example for that if you'd like. And then origin dilation, well, now we're going to change both of the diagonal spots. So I could say, let's call it C. This would be a dilation with respect to the origin by whatever C happens to be. Because now both x and y will change by c. So you could take a look at this. So in general, you could say maybe you could take c, 0, 0, c, and if you multiply that by some coordinate x, y, you would see that you end up with c times x and c times y. So you'll notice that whatever that factor of c is, both x and y move that far away, c times x and c times y. You could also do combinations of this. So for example, you could say, let's do 2, 0, 0, 3 times a point. And now the x value only gets stretched by 2, whereas the y value gets stretched by 3. So this would be kind of weird, because if I was over here at, let's say this was x, y, my x value would go over to here, and my y value would actually get stretched by 3y rather than just 2y. So my new point would end up kind of being over there. So this, if you were thinking about like a widescreen TV or something, this might be a situation almost the opposite of a widescreen TV. You're taking your regular picture and you're stretching it vertically more than you're stretching it horizontally. So people might look super, super tall compared to what they're supposed to look like on your TV. So if you see a matrix in any of those formats, now you know that that would be an x dilation. This one would be a y dilation. And then finally, if you have the same number on both of those spots, this is just dilation with respect to the origin. And that's pretty much it for dilations. Now the second transformation I wanted to talk about was reflections. And once again, we're basically going to have 3 reflections, kind of 4, but one is a combination of the other 2. So let's start off with a reflection over the y-axis. So if we're thinking about reflections, what that really means, if I'm going over the y-axis, that means that all my x values are going to end up being negative x. Plugging numbers in again, if I had the point 3, 2, and I wanted to reflect over the y-axis, I would end up at the point negative 3, 2. And so in order to achieve that, we're going to actually do something very similar to what we did in the dilation section. We're going to dilate by a factor of negative 1, which means that my transformation matrix of negative 1, 0, 0, 1, this will be a reflection over y. And then if I switch the position of that negative 1 and I go 1, 0, 0, negative 1, this would reflect over the x-axis. For all of these, if you do want to see an example, you could take, let's say, 1, 0, 0, negative 1, and multiply it by our initial example, which was 3, 2, and you would end up with the point 3, negative 2 here, which, as you can see, would be this point here, which is in fact a reflection over the x-axis. Now, if we combine those two, so we get something like this, negative 1, and then 0, 0 in the other two spots. Now we've reflected over both the x and the y, and so we would say this is a reflection over the origin. And this might be somewhat familiar from when we did functions. We talked about function transformations when we replaced x and y with negative x and negative y back in chapter 1. Or you might remember this kind of stuff from geometry. Or if you don't remember it, here's what they are, what it means. Okay, now the last one I want to do is, this will be a little bit new. So what I would like to do is reflect over the line y equals x. So that means that if I have my point 1, 2, 3, and 2, and here's my line y equals x, what I'm doing here is I'm taking this point and I'm actually sending it straight across here. And so it's actually going to end up, if I had drawn this more to scale, this would actually be the point 2 and 3. So in this case, when you reflect over the line y equals x, x and y switch spots, which is how we talked about inverse functions as well, which we've seen in previous units. So this is all kind of related to what we did before. But in terms of the matrix, what we're trying to do is multiply something by the point 3, 2, so that we end up with the point 2, 3. And in order to do this, what we're going to do is actually multiply the transformation matrix 0, 1, 1, 0. And you'll notice when you do this, you'll end up with 2, 3. So what we're doing here is we're taking the transformation matrix 0, 1, 1, 0, and this would be a reflection over the line y equals x. And you could see that that would hold for any general situation. If you did 0, 1, 1, 0 times any point, which I'll just call xy, if you did that, you would end up with the point yx. All right, so in this video we talked about dilations, and then we also talked about reflections. Reflections and dilations are very closely related, except I would say that this example here is probably a little less intuitive. This is one that you might not have been able to figure out immediately. The other ones hopefully were a little bit more intuitive and were all very closely related, meaning that you don't necessarily have to remember every single rule. Although if you do want to start a list of rules, you could start writing down the different matrices that we have. So we had A, 0, 0, 1. We had 1, 0, 0, B. And then C, 0, 0, C. And then for the reflections, we had the matrices negative 1, 0, 0, 1. 1, 0, 0, negative 1. And then the combination of those. Although this is starting to be a lot to remember, so what I would do if I was you is just kind of remember the main ones, the dilations, and remember that reflections are just kind of like dilations.